Assalamualaikum warahmatullahi wabarakatuh. And to everyone who watches this, today I'm going to explain about sorting techniques. So firstly, for bubble sort, I'm going to compare the first index with the next of the first index. If it's smaller, then we can swap it, but if it's not, then we will not swap it. So as you see here, the first pass has already passed. So now we're going to make the second pass, which we start from 10 compared to 14, and then 14 to 29. So it's going to be a lot of tedious works, and we're going to have the bubble sort ends at 6th path. So as long as you can see the biggest number floating, as in not moving around, then you can confirm that the bubble sort is going to the right path. And we are done! Yeah, it took us a lot of time. Secondly, we have the insertion sort, which is almost similar to selection, which is going to be talked about later. So the best case scenario that this insertion sort is going to have is ON, while worst case is going to run on ON squared. This one is easy. You have to create two array, which is the unsorted and sorted, and then you have to go through each element and determine the element from the unsorted array where the element is supposed to be in the sorted array by iterating over each element to see if the number is between two numbers. So you can see from the animation here, now we're done. For step 1, we have selection sort. It is also like insertion, but not so efficient, according to some sources. So in best case scenario, and also worst case scenario, we're going to have the big notation of n squared. So now you can see the animation. So for the current item, it's going to be compared with the current minimum and it will be swapped. So 5 will not be bothered, so we're going to bother 10, and it's going to be swapped with 8 because it is the current minimum of the unsorted array. And so the process will be repeated until the array is sorted. And we're also finished for selection sort. Now we're going to move to the advanced sorting. For merge sort, we have here is the array starting from 29 ends at 15. So we will cut it in half, and then for the first part of the array, we're going to divide it at the index 2 because we count the middle from 0 to 5, and then divide it by 2, we get 2.5. Which is equal to 2 because integer cannot take points. So then it will cut again. So for the new array around the 29 until 14, we have to cut the array at index 1. So we will get 29 and 10. So we have to cut it again until we get only one element inside of the temporary array. So now we get this array, 29, 10, 14, 37, and 13. So we're going to compare it with the one next to it. we can see here 29 and 10 can be compared, and we can see that 29 is bigger than 10, so it's going to be on the next index. It's gonna be the first index instead of the 0. So 10, 29. So we can compare the array of 10 and 29 with 14, and we can see 14 is supposed to be between 10 and 29. So when we merge, it's gonna be in the middle of 10 and 29. And then we have the another array, which is 37. Sorry, it's actually two arrays, 37 and 13. So when we compare, 37 is bigger than 13. So when we merge, 13 is gonna be at the lower index of the compared to the 37. So when we merge, it's going to sort out on itself 10, 13, 14, 29, and 37 compared to the array that we have. Merge. So what we have to do here is count the array index of 20, which is 5, 0, 1, 2, 3, 4, 5, and plus with 9. So 5 plus 9, we will get 14, and then we divide it by 2. So we're going to get the cutting in half is going to be made at index 7. So around 8 and 12, it's going to be cut, and then so the array has been cut in half, right? So we got the first array, which is 20 until 8. So we're going to do the same thing. We're going to cut it in half. So this is 5 plus 7. So we got 12 over 2, we got 6. So we divide it at index 6. And then we do the same thing for 20 and 15. We don't do anything to 8 because it's already been left alone. And so for the another array that we have done, which is 12 and 15, we're going to divide it at 8 at index 8, which is besides 20 and 15. So we're going to get the elements standing on its own. So now we can compare the array with the one next to it, just like we did for the previous part. And now we do the same thing to the second part, and the arrays will be merged and it will be sorted in ascending order. So quick sort is also cutting, but we have to choose the pivot first. So in this case, we're going to choose 29 because it's the first index in the array. So having 29, we have to put on its left side the smaller number, and the one on the right side will be the bigger number compared to 29. And so after we get 29 and 37 already sorted, because we're going to make it ascending order, right? So we're going to leave it, and then we're trying to cut the array into half so that we can choose a pivot inside the new array that we are going to cut again. So in the first array we have 5 until 12. The new pivot that we're going to choose is 5, and so 5 is going to be compared with all of these, but because it's smaller, then we're going to leave it. So we're going to choose a new pivot inside the new array, which is 10. So we see 10 is not smaller than 8. So 8 is going to be swapped with 10, and so the position is swapped. Okay, for the second array we see here, we see that 13 is chosen as the pivot. So 13 is smaller than any number in the array, so we're going to leave it alone. And then for the new array, we're going to choose 20 as the new pivot. So 20 is not smaller than 15, and it's not smaller than 14. So it is going to be sorted, and we get 14, 15, and 20 in the new array. And then after all is done, we're going to merge it back into the new array. So that's it from me. Thank you so much for listening.